In this video, I want to show you how to derive these three laws of indices. Right, first of all, let's talk about an index. An index is just a power. For example, suppose you have a to the power x. Right, x is what we call the index, which is the power. And this one is referred to as the base. This one is the base. Right, we'll later talk about these two. Right, so we are going to start with this first one. Right, let's have these two terms here, x to the power 3 and x to the power 2 multiplying each other. Right, x to the power 3 is the same as in expanded form is the same as x times x times x. 3x is multiplying each other. Right, likewise x to the power 2 is the same as 2x is multiplying each other like this. Right, so if we simplify this, we have how many x is multiplying each other? We have 1 2 3 4 5 x is multiplying each other. So the number of x's that will be multiplying each other will be the power of x here. So we are saying this is equal to x to the power 5. Done with the first one. Let's move on to the second one, where we have x to the power 5 multiplying x to the power 4. By expansion, we have 5x's multiplying each other multiplied to 4x's multiplying each other like this. Right, and if we count them all together, they are now 9. We have the first 5 black x's and these 4 blue x's, and if we add the total number of x's here, it's now 9. So 9 is now the new power of x here. This simplifies to x to the power 9. Right, let's move on to the third expression. Right, x to the 8 by x to the power 3. Right, we have 8 blue x's multiplying each other and 3 black x's multiplying each other like this. And if we count them all together, the total number of x's that are multiplying each other is now 11. So the answer is x to the power 11. All right, let's move on to this one. X to the 9 by x to the 6. Right, we have 9 black x's multiplying each other and 6 blue x's multiplying each other like this. And if we count them all together, the black and the blue x's here, we find out that they are 15. So the final answer is now x to the power 15. Right, from this expansion, if you look at the powers here, the original powers, let's talk of the original powers. Want to see the relationship between the original powers and the new power. If you look at this one, this is 3, this is 2, and if we add them, we get the new power. Let's move on to the next one. We have 5 is the power here and 4 is the second power. If we add them, we get 9. We have 8 here, that's the power of x, and 3 here. If we add them, we get 11, which is the new power here. We have 9 and 6. If we add 9 and 6, we get 15, which is the new power here. So from these important results, we can generalize and write down that and conclude that the power, if we are multiplying x to the power something by x to the power something, we just add the powers like this. And this is our first law. We are going to take this one as our first law. Right, where we are saying x to the power m by x to the power n is equal to x to the power m plus n. We just add powers and we do nothing to the base. We rewrite the base as it is, and we write, please take note here, we write a single base, then we add the powers. Right, this is applicable if and only if we are multiplying the indices of the same base. We have x here and x here, then we are multiplying. That's always the case, that we must have this x being the same as this x. If it is x and y, then forget about this law. Right, let's move on to our second law, the one that we are going to take as our second law, right? Where we'll be dividing x to the power 6 divided by x to the power 2, right? This is the same as by expansion. 6x is multiplying each other in the numerator like this, divided by 2x is multiplying each other in the denominator, right? So this x will cancel with this x in the denominator. This x in the numerator will cancel with this x in the denominator, remaining with these 4 x's. So this will simplify to x to the power 4 like this. Let's move on to our second expression, right? In this case, we have 8 x's multiplying each other in the numerator, and in the denominator we have 3 x's multiplying each other like this. So this x in the numerator will cancel with this x in the denominator. This x in the numerator cancels with this x in the denominator. This one in the numerator cancels with this one in the denominator, remaining with these 5 x's. So the power of x is now 5. So this simplifies to x to the power 5. Right, let's move on to another example here, right? We have x to the 11 divided by x to the 6. So we have 11 x's multiplying each other in the numerator and 6 x's multiplying each other in the denominator like this, right? So this x will cancel this one will cancel with this one cancels with this one cancels with this one cancels with this one cancels with this one, remaining with these 5 x's. So this simplifies to x to the power 5, right? Likewise, from these 3 important results, from these 3 expressions, these results, let's also see the pattern here. This is 6 and this is 2. If we subtract these 2, we get this new power 4, right? This is 8, this is 3. If we subtract 3 from 8, we get the new power 5 like this. This is 11 and this is 6. If we subtract 6 from 11, we get the new power 5 like this. So we can conclude as well, we can come to a conclusion where we'll say x to the power something divided by x to the power something will simplify to x to the power something minus something, like right like this. Right, x to the power m divided by x to the power n. We have seen that we are just subtracting the power, so we rewrite this base as it is, a single base here, then we subtract the second power from the first power, m minus n, and that's always the case, and that's the order. Never raise the order writing x to the power n minus m. That's not true. It's only correct if we are subtracting the second power from the first power, right? And this, please note that this is also only applicable if we are dividing indices of the same base. This base must be the same as this one. If we are dividing x to the power something and x to the power something, then you can apply this law. But if you are dividing x to the power something by y to the power something, then forget about this law. Right, let's move on to the last law. Right, to do it this way, x to the 2 divided by x to the 6 by expansion, this simplifies to, right, this x will cancel with this x will cancel with this x, remaining with these 4 x's. So it will be, and these 4 x's are in the denominator, so it will be 1 over x to the power 4, right? X to the 3 divided by x to the 8. Likewise, this one, this x will cancel with this x will cancel with this x this 30x will cancel with this one, remaining with these 5x's in the denominator. So our answer is 1 over 5 to the x, right? We have x to the 9 divided by x to the 11, right? If we cancel like that, we'll remain with 2x's only. These 9x's will cancel with these 9x's as well, remaining with these 2x's in the denominator. So our answer is 1 over x to the 9. Right. Let's also simplify the same using the second law. Here is the second law, where we are simply subtracting the powers. In this case, it will be x to the 2 minus 6, which is x to the minus 4, right? Let's move on to this one. It will be x to the 3 minus 8, which is x to the minus 5, right? Right, the last one will be x to the 9 minus 11, and this simplifies to x to the minus 2, like this. Right, mathematically, these answers are all correct. We are saying 1 over x to the power 4 is a correct answer, then x to the power minus 4 is a correct answer as well. So mathematically, this means these answers are equal, meaning 1 over 4 or 1 over x to the 4 is exactly the same as x to the power minus 4, right? Likewise, 1 over x to the power 5 is the same as x to the power minus 5, like this, right? The last one, 1 over x to the power 2 is also the same as x to the power minus 2, like this, right? From these results here, from these three results here, we can conclude that even if we have x to the power, for example, minus 20, this will also simplify to 1 over x to the power 20. Then let's generalize now. So we are saying if we have x to the power minus n, this can be expressed as 1 over x to the power n, like this. Thank you very much for watching. Please don't forget to subscribe, like, and share.